Okay, exponential functions. We have again, we've gone through how many forms of equations have we gone through this year? Yeah, well, not more than I can count, more than I care. Here's another one. Okay. Y equals a times b to the x. This is an exponential because the x is in the exponents. Okay. Our properties of powers are going to suit us well through this whole chapter. We're going to study everything relating to exponentials and their inverses. Okay. Can anybody think of any examples in real life that follow exponential? Do you guys know what it looks like? Okay, I guess we should probably start there. The graph of an exponential looks like this. Any ideas of items that will model? Okay, that's probably the biggest one. There are some economic applications there. The big one is human population, because we can continually increase our food production, right? Animals will actually level off and curve back down because there's not enough food for them. You have the rabbit population increases, the coyote population will follow, but then the coyotes eat all the rabbits, so their population dies off, and then the coyotes eventually die off too. So it'll actually level off and come back down. More of a sinusoidal model, but it does follow this at times as well. Breeding like rabbits, right? All right, let's go ahead and graph one. You can do these very easily on a calculator. I trust you can use that machine. Okay. But if you run into it by hand, any ideas on how we might do this? There's one technique we can always use. Table? We'll start with the table. Okay. Again, I always use those just because that's easy, right? So, what is 4 to the negative 2? 1 over 16. Yep. So that would be negative 2, 1/16. The nice thing is these won't go into the negatives on the y values unless and I'll show you one that will, shift it down. What's 4 to the negative 1? 1/4, and then 4 to the 0, 1, etc. Okay, Okay, and you can see that my graph will actually go really high. the next point at 2 actually ends up right there. So you can see how fast these grow.
Is that what that always looks like? And then like other numbers and a bunch of
Yeah, they pretty much follow the same shape. It's just a matter of how fast they grow.
there's like a bunch of other numbers, like a bunch of other numbers and stuff. The equation, or is it gonna be one number and the next other?
We can mess with it a little bit. Yeah, so you can see how fast these start to grow, right? Let's look at, okay, you can use your families of functions knowledge here too. What if I wanted to graph that? 4 to the x plus 1. Left one. Remember, if it's paired with the x, it's opposite side to side. So we're just going to move it left one. And it follows the same curve. What's another one? What about that? What? Down to. Yeah. It's not paired with the x, so it's separate. It's like, okay, so new, we're going to take it down to 1, 2, 2, 2, 1, 2. Okay, there's that one. Do you remember? Okay, will this ever cross that line? Do you remember what those are called? We use it in hyperbolas. Asymptotes, yes. And notice it's y equals -2. That's -2. For these other ones, it's y equals 0 because there's nothing out here. Okay. So we have asymptotes. They get closer and closer and closer, but they never touch it. There's one other change you can make. Put a number out front. That's a new a value. It multiplies every answer by 2, right? So you just take this answer and multiply it by 2. So we have 1/8, 1/2, 2, 8, and it makes it go up even faster. Okay. Yeah, it's fine. Okay. All right. So you kind of see, you get the idea, right? Just do a table of values. It works out really easily. This, I want to point out in the general form, this one, b is greater than 1, right? So it's actually going to grow. It's called exponential growth. Here's a sample where b is less than 1.
How many of you are in chemistry?
You're juniors, right? You're most of you. Have you studied decay, half-life? A little bit. Okay, this directly applies to that. So remember this when you get to that. The exponential decay.
Again, table of values. What is 1/3 to the -2?
You remember what you do in a negative with a fraction?
Flip it.
You can flip it, so it's 3 squared.
Right.
Flip it over. So 3 squared, that's 9. What's the next one?
Somebody say it.
3.
3. What's this one?
1.
1. 1/3 and
2/3.
no. 1 squared and 3 squared. 1/9. 3 squared is 9. So it starts high. It comes down. It's decaying. Do I need to show you left, right, up, and down shifts? You got that? Okay, there's one more I do want to show you. What if I wanted to graph, I'm going to run out of room here, so I'll have to get a new piece of paper. This function. What's going to happen?
What does a negative do in front? If you multiply all those by a -1, it reflects it over x-axis. Basically, it makes all the y values negative.
So this -1 has this effect. Okay. Excuse the paper, but that's what it's going to look like. In effect.
So you just multiplied it by a negative, flips it upside down. Okay.
Good. Because according to Newton's law of cooling, the difference between, there's an application to physics here in your book. Okay. It has to do with the Newton's law of cooling. You gotta. Businessmen don't need to know this, right? That was not a loaded question, but good thinking there. No, I want to show you one application here. So Newton's law of cooling. The difference between the temperature of an object and its surroundings decreases in time exponentially. Okay. So if you have a cup of coffee, it's going to cool off really quickly at first. If you look at the exponential decay, it cools off really fast, and then it starts to level off, and this would be room temperature. It will level off and get closer and closer to room temperature until it actually reaches it. Okay. So let's say that we have a cup of coffee that's 95 degrees centigrade. It's pretty warm. And it's in a room that's 20. Okay. We can model this with this equation. T is time in minutes. What's the temperature after 15 minutes? That's the first part. So what are we going to do? Plug it into T. Now pay attention here. To what y actually means. $10.12. Okay, is that the actual temperature of the coffee? Right, you have to subtract it because it's the difference from the starting point. All right, so the coffee temp is 95 minus 10.12, which is, okay. Did I get it right? Yeah. Okay. Do you think you can graph that one? Use your calculator. It's easy. It just has funny numbers, that's all. So, all right. Good enough. I think you got it. Right. What? R? Oh yeah, review problems. We will do this one in 2 sections. Thanks. Because I you have a lot of work to do tomorrow. I think we're safe waiting till Tuesday. Yeah, that's fine. But you got to work hard. The rest of the hour, you have 15 minutes. Get a few problems done, and I'll give you till Tuesday. You know what an exponential is, right? Is it an exponential? X to the 4th, is that an exponential?